Born roughly 4.5 billion years ago, the Earth has seen many changes. Its early history was shaped by physical forces, and life developed slowly. 2 billion years ago, cells began to have nuclei. 1 billion years ago, shortly before multicellular life had emerged, the continents as we know them today did not exist. The supercontinent Rodinia is thought to have united almost the entirety of the landmass of the planet. The planet's changing orbit in the solar system and the sun's shifting location in the Milky Way gave rise to great changes in climate. 800 million years ago, the planet was frigid, and glaciers reached as far as the equator. The next several hundred million years saw a constant change in temperature, geography, and ocean currents, along with the development of the first simple animals, and then early arthropods, ancestors of today's insects, spiders, and crustaceans. In a period known as the Cambrian explosion, tremendous changes in life swept the planet, including rapid extinctions of existing species and creations of new, more developed forms of life. Nervous systems continued to develop, and brains formed. Fish, land-based plants, insects, and seeds all began to make their first appearance. Land-based plants were able to expand the activity of chlorophyll, with supportive structures and protection against drying out. This expansion of plant life created a greater and greater circulation of oxygen and water. Life had finally moved to land, and life was increasingly shaping geological and atmospheric changes. Animals underwent their own development and moved to land as well. By 300 million years ago, reptiles had come into existence. The land area of Earth was in a single supercontinent known as Pangaea. Much of Pangaea's land was not even on the surface in the time of Rodinia. New land was freshly revealed by erosion or pressed upward as mountains or from volcanoes. During this development, cycles of biodiversity mirrored the changing flux of cosmic radiation as the solar system moved through the galactic plane. This world of flowerless plants, insects, fish, and reptiles was about to experience a huge change. At around 200 million years ago, the dramatic development of mammalian life occurred. These new creatures were able to regulate the temperature of their bodies, allowing new, temperature-dependent biological processes. By this time, Pangaea was separating into two continental systems: Laurasia, which contained today's North America, Europe, and Asia, and Gondwana, made up of today's South America, Africa, Australia, Antarctica, and India. As Gondwana was breaking up into the separate continents we know today, birds and flowering plants were developing. The age of the dinosaurs came to an end at a time when North America was closer to Europe than South America, and present-day Colorado was a rainforest. Creative human life appeared on the order of hundreds of thousands of years ago and had to contend with regular ice ages. Only 15,000 years ago, Asia and North America were connected by a Bering land bridge. The Sahara Desert was forming as the North African savanna dried. Today's Death Valley contained a lush freshwater lake, and mastodons feasted on the flora of Utah and Nevada. The recent medieval warm period of 1,000 to 700 years ago and the Little Ice Age of 500 to 200 years ago saw changes in ice extent, land available for farming, rainfall, and climate. At present, some parts of the planet are dry, some are wet, some hot, and some cold. This current state of things is a moment in a process. Through all of these changes, nothing has remained constant on the planet, besides an overall tendency towards more complex forms of life and a greater flow of biological material. At each dramatic change in environment, life moved forward, creating more advanced dynamic equilibria. Now, this process can be actively guided by the intelligent member of the biosphere, human beings. Look at today's NWAPA program, which will redirect water that would flow unused to the sea, bringing it instead to dry areas that have the potential to support great biological activity. Thus, the biosphere is made more productive. To those so-called greens who want to keep the desert brown, ask, what's so great about the current distribution of water? Why maintain it? Can places of great beauty be considered untouchable? Not to nature. No vista is forever, no rock formation eternal, no desert permanent. While human beings may cherish a beloved landscape or particularly remarkable geological formation that causes wonder to its beholders, no such sites are sacred to changing nature. The worship of constancy for its own sake is, frankly, unnatural. Instead of constancy, create beauty.